Hi everyone, this is Jeff from the Ozark Mountains in Missouri, USA. Today we're going to be looking at a PacMan or maze type game written in Commodore 64 BASIC. I bet some of you are wondering, hey Bert, why would you try to write a game in BASIC? That doesn't seem like a good idea. Well, that's a good question. It all started a couple years ago when I was watching a series of videos by GRayDefender where he wanted to create a PacMan type game for the Commodore 64, and he did his initial prototyping in BASIC. That got me to thinking, well, it might be a little slow, but I wonder if it's possible to make any sort of playable game just in BASIC alone. GRayDefender shared his code, and I used one of his maps as a starting point. It had been quite a while since I'd done any programming at all in Commodore BASIC, and getting used to using an old dialect of BASIC in line numbers was quite painful to start with. It was fun though, remembering how to use such an old version of BASIC, and I learned a few speed-up tricks thanks to the good folks on the Lemon 64 forum. What I wound up with at that time was pretty slow and not really playable though. Fast forward to a few months ago, and a fellow named Robin started the 8-bit Show and Tell channel. One of his first videos was about Commodore 64 BASIC speed-up tips, and it got me wondering again about that old game I started, and if I could use some of the new tips that Robin had shared to speed it up to make something at least playable. Before jumping on the computer and diving into the code itself, let's go to the bench and review how a BASIC program is laid out in the Commodore 64's memory. Let's get started. What I have here is a page from an article in the Transactor magazine, Volume 5, Issue 2, and I'll put a link to where you can find this down below. It's a good article that describes how BASIC works on the Commodore 64 and kind of more in generally how the Microsoft type BASIC works. So the layout of BASIC and RAM is there's a pointer that tells the computer where in memory BASIC should start. And on the Commodore 64, that's at hex 0801. But the pointer or the vector to that is at 2B and 2C. So you can actually change that if for some reason you would need to relocate BASIC. The first part of BASIC is the text. That's your lines when you type them in. They go there. After the end of the text, BASIC puts the variable table. Each time you declare a regular variable like a equals 10, it takes that and it stores it here after the basic text in the order that you define it in. After the regular variables is where the arrays are placed. And so that means that if you define a regular variable after you've defined an array, it's got to move everything up to make room, which can be quite a time waster if you're doing that in the middle of your program actually operating. Then there's whatever empty space you have left, and at the very end of the basic program memory area, you have your strings. And while everything else builds from the bottom of the memory this way, strings are a little odd in that they build from the top of the basic memory down. This is so you don't have to keep pushing strings around every time your other variables would change, because moving strings is very expensive time-wise. When your basic program uses a variable, BASIC will look through the variable table here one at a time and match up the first two characters of the variable name. So you can have a longer variable name, but it's really only going to use the first two characters. So if you have variables named A through G and you use variable G, BASIC is going to have to look through A, B, C, D, E, F till it gets to G, and then it can retrieve or set the value of G. Another curious tidbit about BASIC is that it keeps these basic text lines in a sort of list. We can look at that here, and we have each line ends in a 0, which is the end of line marker. And then the first 2 bytes after that are the address of the next line in BASIC. And then we have 2 bytes which are the line number and then the actual text. So each line of your basic program actually points to the next line. In computer science jargon, this is what's known as a singly linked list. Now, each node in that list, in our case a basic line, starts with the address of the next node. So if you want to find a particular node or a particular line number, you have to start way at the beginning of the list and search your way one at a time through each node till you find the one you're looking for. And this is what BASIC has to do. If you're toward the end of your program and let's say at line 1000 and you say go to 10, it's going to have to start all the way at the beginning till it finds line 10 and then start executing there. This means if you put all your variables or other setup information like drawing your screen and everything like that at the beginning of your basic code, that each time your actual game section or the meat of your code, the actual logic, wants to do anything, BASIC is going to have to sort through or iterate through each of those lines till it gets to the next line that you want to do something with, which is quite a time waster. So it's rather counterintuitive that you kind of want all your setup things, your variable declarations and all that you want it done first. You want to place those at the end of your code and call them using a go sub from the beginning. So let's jump on the computer and we'll look at the actual code now. I'm using CBM Program Studio. As you can see here, there is a link in the description down below to the web page for this. It's a free program for the downloading, and it works well with Vice. You can write your program on the PC and run it through Vice and test everything out and then move it over to the actual computer. Another nice thing it lets you do is set it so that it automatically removes all the remark statements. The remark statement is just another line or just another node in the list that has to be iterated through as BASIC is looking for the line number that it needs to go to. So it's nice having the remarks in there when we're writing the code and have them automatically be removed when we want to run the code to make it a little faster. So you'll notice here at the beginning of the code I'm calling a couple go subs. One is to initialize all the variables and the other is to draw the first level, or you could have a splash screen drawn here. So if we scroll down to that area of the code, I left some remark statements in there describing what some of the things were, why I did a few things. I find this is even really helpful to myself. So if I look at this several months later, I have an idea of what I was thinking or maybe why I made a certain decision. The first things I initialize are a couple of arrays that I'm using and a few strings. This is because you can't redimension arrays, and if we want to set everything back to the default later, we can't run this section of code again. So it's done first. Then we get down to initializing the regular variables, and this is set up so I can just jump to this line 920 right here to reinitialize everything. For instance, if you had multiple screens, you could reinitialize everything between screens. And after it returns from here, we call the part of the code that draws the screen map. The first thing it does is clear the screen, and all of this right here, which looks kind of funny, reverse on, cyan, things like that, these are the Commodore graphics codes, which you would get by hitting Commodore and a certain key or Commodore Shift and a certain key. CBM Program Studio allows you to draw a map. It has like a screen map editor built in, and it'll export this basic code that you can then put copy over into your own code, making it a lot easier. And then when it creates the actual Commodore basic code from this, it converts it to the correct characters, but this just makes it easier for you to see and reason about. After drawing the screen, we place our PacMan and Ghost at the starting position and then return. And so we're at this point. Now if you had multiple levels, you could jump back into this area to reinitialize the variables and maybe draw another screen. You'd have to have a little more logic in there to decide which section of code you should jump to draw the screen. And 720 right here, this is a subroutine that prompts the user to press return to start the game or Q to quit. So since you might want this in between different levels, I just added a subroutine for that. Let's go ahead and look at this screen editor really fast. I won't go through it, but I'll just show you that it's there. So here's the map. And this is one I copied from GRayDefenders code. So it's just a copy right from his code, and you notice that the entire screen or area where the PacMan or Ghost are going to run are bounded by graphics characters except for the warp tunnel. So this makes our positioning on the screen somewhat simpler because we can just look to see if where we're wanting to go is not a wall. If it's not a wall, then we're allowed to go there. You know, if it's a pellet, we get a score. If it's a asterisk, bonus, we get a higher score, that type thing. And CBM Program Studio also has its own character editor built into it, so you can create your own character sets to have a little fancier looking graphics on character-based games like this. Then we get to the main loop of the program, and the first funny thing you'll notice is I have from I equals dot to 1000, and then I've remarked out the step 0. So when this line is in this configuration, this is saying from I equals 0 to 1000, but just the decimal point is a little bit faster than using a 0 or using a variable. This is one of the tips that Robin gave from 8-Bit Show and Tell. And with this set to 1000, this will run the main loop 1000 times and then print out the amount of time that it took, which is helpful for trying different ideas to seeing if it speeds things up or slows things down. And in regular gameplay mode, what you would do is remove that remark like this. We give it a step 0, which means it's not actually going to count up the loop, so it'll be an infinite loop. And that seems like a silly way to do it. Why wouldn't we just use a goto at the end of the main loop and say go to 240? Well, you remember we talked about BASIC keeping each line in a linked list. If we use a goto, it's got to go to the top of the code and search through that list line by line till it would find line 240 to start running there again. When you have a loop, it does things a little differently. It knows it's going to need to jump back to the start of that loop a lot, so it'll keep track of where the address where that starts. So when you get to the end of the loop, it knows right where to go back and start again, so it saves a little bit of time from each loop iteration, not having to search back through your code. When we get into the actual code, the first thing we do is read joy port 2, which I have its address stored in J2, and we save that in variable J because we're going to make use of that reading that we took several times, and if you're going to make use of that value several times, it makes sense to save it in an intermediate variable rather than doing that peak several times in a row, which will take a lot of time. So we read joy port 2, and then we are blanking out the current position of our PacMan or player character. And then we do a J, which is our joystick port reading, and JS equals 0. So what we're saying here is we're going to take the reading from our joystick port and we're going to AND that with the value, which means that we're moving south. And if that returns 0, we know that we can indeed move south. So we're going to set a temporary variable t to the current pack y position minus the y offset, which is 40 less than where we're at now. And then we look at that position to see if there's a wall there. If there's not a wall there, then we can make that our new y position and we can skip all the other directions. So, and then we do the same for, north and west and east, which this means if you have, let's say the joystick going north and west, you're pressing two switches at one time, it's going to give preference to north. And if you have it going, let's say, south and west, it's going to give preference to south. So after we find out if we can go a direction and we offset our current position accordingly, we check to see if we're at the entrance to a warp tunnel, and if we are, then we offset our X position to account for that. And we're going to calculate the new position of our PacMan. We're going to reuse that temporary variable t, And then we're looking at what's in that spot now, and if it's a pellet or a decimal point in our case, which I have the character code for that saved in GF, then we get 1 point, which is this variable P1, or you can change that to whatever point value you want. And then we skip down an extra line, and if it's a star or a bonus, then we get a different value. And this is a very sad and simple goal of the game. If our score, which is SR, is greater than this final score variable, or what we need to get to, then basically we win. And I think right now I actually have it set to 200 points, not 100 points. And that's not a very good gameplay goal, but it's something simple and it made the code really easy to look at. So if we've won, then we jump back to line 170. We set, the MG here is the message type we want displayed on the part of the screen where it says press return or press Q, and then we go to 170 to display that. If we haven't won, this section of the line just toggles the value PT between 0 and 1, and we use that here with this PC array, pack character array, to toggle between an open mouth and closed mouth character. One thing you might have noticed here when I'm dealing with the pack position Y and pack position X, that I'm not using the traditional formula where you would say you take the Y position times the number of screen columns, 40, so you take Y times 40 plus X to calculate the screen position. On these old 8-bit computers, particularly in BASIC, you want to avoid multiplication and division like it's the plague, because it's very, very slow. On the Commodore, you start out right here in this corner of the screen at location 00, which is actually memory address 1024. The memory addresses increase as you go across the row till you get to the last column, which is the 40th character. So if this is 1024, this is 1024 plus 40, or 1064. 1065 then is right here. And so we go on down the screen like that with our memory addresses, increasing our crossed and then starting over on the next row. So rather than taking our row times 40 plus column, or Y times 40 plus column, which is very time consuming and slow, we can take advantage of the fact that we know each Y change going from one Y location here to here or to here, we know that that is plus 40 or minus 40, and we know that we are also only moving one spot at a time. So if we were here and we want to move down one row, we can just add 40, which is our Y offset, Y0 in our variables. We can just add the Y offset to our current position, to our PY. So our PY would be this value. To move down one row, we do PY plus 40. To move up one row, we do PY minus 40. This is very fast. It gets rid of all that nasty multiplication, and it is also easy to follow once you know what's going on. And now we get down into the ghost logic, which is actually the most complex part of it, and I tried to make this really clear, mostly for my own benefit. There's also a line in here. You can remove this remark statement, and it will jump down here to line 660, which bypasses all this ghost code. So if you're wanting to test or time something that's just in the PacMan movement code, you can do that and just bypass all the ghost stuff. So sort of like we did with the PacMan, we are going to calculate our current ghost position in the temporary variable GT, and we're going to poke into that position what was there last. So if the ghost is running over a pellet, a decimal point, we don't want it to eat it, so we'll put that back. Or if it's a bonus, which is the asterisk, we want it to put it back. So we keep track of what character is where the ghost is going to move, and we put that back at the start of the ghost movement routine. Then we're going to zero out some north, south, east, and west variables. They help us keep track of the weights of each direction. In other words, how badly do we want to move in that direction? So for instance, we say that can the ghost move up one row and it not be a wall? If so, we're going to add a weight of 4 to the north variable. And if our ghost Y position is bigger than our PacY position, which means that our PacMan is north of the ghost, then we'll also add a 1 to that. And similarly, we go through the other directions and we create a weight out of which direction is the most important to move. In this section of code, we do the same thing for each direction, but we're looking at which direction did we come from. We don't want to backtrack and just have the ghost character go back and forth and back and forth. So we apply a negative weight to the direction from which we came. And after adding in all the different weights for each direction we can move, we come down to this section of the code, which just looks through to find out which direction has the most weight, and that's the direction we're going to move. And in this section of the code, I made use of the if-then short-circuiting that Robin showed on the 8-bit show and tell. So you notice I have this series of if-thens here, and this takes place of saying, this is saying if the north weight is greater than the south weight, and if the north weight is greater than the east weight, and if the north weight is greater than the west weight. Instead of using an and in there, if we had an and word in here, BASIC is going to evaluate all three of these and then go through it and see if they're true. When we use this then if between it, it's going to evaluate this first, if north is greater than south. If that is true, then it'll evaluate if north is greater than east. So if north is not greater than south, it's immediately going to jump down to the next line, which saves a lot of time. It looks a little funny when you first see it, but it works really well. So after we go through and we decide which direction we want to move, which has the greatest weight, we calculate our new ghost position in the temporary variable GT, and we look at what is already in GT and we save it in GF, and that's what we poke back in up here to erase where the ghost was. And then we poke in our ghost character at the new location. And then here we're looking at if GT equals T, and T is our temporary variable that we set here for the PacMan or player position. So if our ghost position equals the player position, we'll set the message type to 1 and go to 170, and that means that we got munched by the ghost. If we haven't got munched by the ghost, we do a home, which brings the cursor up to this top left corner of the screen, and then we print out our score. By doing it this way with the home, it makes it position the cursor really fast so we can print the score. If we did this with a lot of pokes, it would be very, very slow. Here we are on the actual computer, and I'm going to try something different this time. I've got my screen capture device set up, and I am going from S-Video from the Commodore through a S-Video to VGA adapter, which is an Extron unit, and a VGA splitter so I can display it on my screen and capture it through a VGA capture device all at the same time. So this will be the first test for it, so hopefully it works. So let's see how this plays on the actual computer. And I'm going to grab my joystick, which is my number 2 joystick from when I was a kid. Fixed this in a video a few months ago. And we'll press return to start. So it's much easier playing it with the joystick than it was playing it with the keyboard, that's for sure. Although I have to say that is not super fast, and trying to move one character space at a time is kind of difficult. Like I said, the ghost logic isn't the best, but it's just as fast as you are. And if it gets homed in on you, it will munch you. Let's see if I can get to a point here where it gets homed in on me. Oh, I got 200 points. Just try that again and I'll get kind of see I sacrificed myself there. And whenever you change direction, you have a little hesitation as a person, and it'll just munch you. So I lost. And now if I press Q to quit, it says thanks for playing, and our characters are all in the right case. As much fun as this project was learning how to speed up a basic program to make somewhat of a playable game, I have to admit that it's really not much of a game at this point. You just kind of have some basic character movement and some really simplistic ghost logic, but it does work and it does do something, and at least it's playable at this point, whereas my first attempt surely was not. There are several improvement possibilities though, such as adding a little bit of sound, a beep or boop when you eat a pellet or a bonus, something like that. The gameplay concept is also kind of weak. Instead of just having to obtain a certain score to win a level, maybe you have to clear the whole level, or you get a bonus for clearing the level within a certain time period, that type of thing. You could also use the screen designer in CPM Program Studio to create new levels or a splash screen to start with. I mentioned briefly that CPM Program Studio also has a character editor built in. Using the character editor, you could define your own custom character set, which would let you create a character for your player, the PacMan type character, having an open mouth in the direction of movement. So you'd have an open mouth in the north direction, a closed mouth in the north direction, open mouth in the south direction, etc. And then you could move through those based on which direction you're going. You could do that, say, with a 2x4 array, where the first element, where the first element was either a 0, 1, selected whether it was the open or closed mouth character, and the second element in the array, which goes from 0 through 3, could select the direction. That would be fairly easy to implement, and it would kind of be a modification of the code that's already there to select between the open and closed mouth. You could also do that with a one-dimensional array. Just have a 1x8 array with all of your character codes in there. How do you think you would implement that? Another idea would be to implement this game in Forth and compare the performance differences. Is that something you'd like to see? Maybe somebody out there would like to work on that, or if you want, I'll give it a shot. Well, I hope you've enjoyed this brief look into a basic program on the Commodore 64. There are links in the description below to CBM Project Studio, GRayDefenders channel, and Robin's channel on 8-Bit Show and Tell. I particularly recommend 8-Bit Show and Tell, as he does a wonderful job explaining these basic speed-up tricks and programming in general. He does a much better job at that than I ever would. If you have any questions or comments, please leave them down below. And if you're a subscriber, thank you. I really appreciate it. If you're not a subscriber, then look down below for that rectangular subscribe button and click on that guy. When you do that, you'll see a bell-shaped icon pop up. If you click on that, you'll be notified just as soon as I post a new video. I would appreciate that too. And tell your friends, tell your mom, tell your coworkers to subscribe to the channel. That would be awesome. Well, until next time, bye.